Okay, today I will be doing the virtual weekly LeetCode contest 358. The last two contests I've tried, I wasn't able to get through all 4 questions, so we'll see if I can in an hour and a half this time. As always, though, I'm not super worried about time because it's a virtual contest, doesn't affect my score. I'm going to try to take it nice and slow and explain everything along the way. Let's go. Okay, min pair sum. That seems like I can just sort it and take the lowest with equal maximum digits. Okay, and the maximum sum of a pair of numbers from num such that the maximum digit in both numbers are equal. Ooh, okay. Interesting. The maximum sum where the maximum digit is equal. Okay, so in this case, I could do 1 isn't the maximum digit, though. It's equal, but it's not maximum. So 71, 17, those are both 7. I also could have gotten 66. Here, none of them are equal. Okay. Interesting. I mean, I'm sure I could just check each pair because the numbers only go up to 100. Still, I'm going to map each one to the max sum first. Just because it makes the checking nicer. So I have n, and then I'm going to say n, and what would the max digit be? N dot 2s dot split dot max. Okay. Again, since this isn't a real contest, I can just print things and see how it goes. Great, so that's 5, 7, 7, 4, 4. Perfect. Love it. Okay. Max equals -1. Nums dot each. Actually. So now I'm just going to get each pair of nums. Again, I'm not even remotely trying to be efficient because I don't need to with these constraints. And here I go. J. So if nums I1 equals nums J1, if they have the same largest max digit, and yeah, those are correctly getting the maxes for each, then I can say sum equals nums I0 plus nums J0. Okay, this isn't exclusive. Okay, so just to be totally clear, I start my max to be -1, so if that doesn't get replaced, it means I didn't have any pairs. Each number now looks like the number itself in the max digit. This just makes the check a little easier to handle, and slightly quicker, not a huge gain. So if they have the same max digit, then I'm going to add them together, and max equals sum if sum greater than max. And then I should just be able to return max. Moment of truth. 88, -1. Easy peasy. Yeah, too easy. Okay. These other ones should be more interesting. And I could have done the check each time that way. I just thought it was easier since I'm going to be continuously calling the largest number of each. The biggest digit of each number. It just seemed easier to have that be stored. Okay, 13 minutes. I am not going to finish in that time. Delete a number represented as a list. As a little number? As a lid? This has got to be list, right? Linked list, yep. Okie dokie. Oh my god, I'm not doing the virtual contest. Okay, wait. Let me do this properly. See, I cheated. I saved all that time on the first question. When really, my time should be like a minute higher. Is it counting it as done, though? It's always weird to me how slowly this site loads, and like how frequently it has server errors. You would think the people on LeetCode would be able to program with a better data structure and avoid some of these issues, right? In any case, submit. Okay, great. Double number represented as a linked list. Okay. So the head is 189. Okay, I mean, the wimpy way of doing this is to just turn it into a number and turn that back into an int. So I'm going to say int equals 0, while head int times equals 10. Let me write this out and explain it. Int plus equals head.val, head equals head.next. Okay, so this is just turning it into an integer. So if we have the example of, say, 189, then this is going to start as 1, then I'm going to multiply by 10 and add 8, then I'm going to multiply by 10 and add 9, and that gets me the number. Okay. Now I just need to do the reverse. So int times equals 2. And okay, so I'm going to say cur node equals nil. I almost said null, but I actually want nil because it's Ruby. So while int greater than 0. So now I'm doing the reverse process, which means I'm going to start at the back of the linked list that I'm generating, and put in units digit, tens digit, hundreds digit, thousands digit, basically. So new node equals list node.new is what we're calling it, not node.new. The value of int mod 10, and the next is cur node. Cur node equals new node, and int divided by equals 10. Okay, and then I should just return cur node. I believe this should work. Okay, so then this part, just to be really explicit, I'm starting with empty, then I put in the 9, then I divide by 10, so it's 18, so then I put in the 8, and that's a comma, then I'm left with 1, divide by 10, so it's 1, and now 1 divided by 10 is 0. Yeah, so this should work. The theory definitely works. The practice just is whether I made a dumb mistake. 378, 1998, great. And I'm returning the head, as I'm returning as a linked list, not as an array, so this is correct. Interesting. Okay. Didn't think about that edge case. So is this a general issue, or just something I have to hard code? I mean, if it's 10, Wait, why does that not work though? I think I just have to hard code this. I don't think it would cause any other issue, because the only other place I'd have a 0 is if I have something like 10 or 280, and in any of those cases, no. Okay, so this is just checking if the head exists. So this part will generate it correctly. If this had actually been 180, then this would have been 180 plus 0. It wouldn't have stopped, so that's fine. Moreover, the leading digit can't be 0, so yeah, I just need to program this in. So return head if head.val equals 0. And I think I can just do equals 0 because it's without leading zeros. Just to be totally clear though, good practice is to try to make sure I actually pass my test case. That failed last time. Now it should pass everything. Okay, yep. 5-minute penalty, well deserved. Also doesn't matter. Minimum absolute difference between elements with constraint. Okay. The minimum absolute difference between two elements that are at least x indices apart. Okay. Interesting. So this has to be 10 to the 5. I can't just test every, yeah, shoot. 1. Okay, so I can't test every pair of elements that are at least x apart, obviously. So if x is 1, this is super easy because I can sort. If x is 2, well, again, it's sorting, but that's only because the 4s happen to not be next to each other. If the 4s were next to each other, yeah, dang. What happens if I just sort the numbers, keeping their original index, and then checking the differences wouldn't work because I could get a situation like this where I have to check each of the pairs. Okay. This is interesting. So it's 10 to the 5th. I can't brute force. I have to optimize this some way. Can I do this with a binary search somehow? Because 10 to the 5th means O squared root n is pretty uncommon. So it has to be O of n or O of n log n. Because n squared is too slow. And log n means I'm doing an O of n check with a binary search. So if I want to find, say, the minimum value, I basically just need to check if a certain value is possible in O of n time. Okay. It seems like there needs to, or I need to sort the array somehow. That would also get me to O log n. I think I'm probably going to do both. So I could like sort these in a way that keeps their original index. That seems like it would be faster because it's easy to check the differences. However, think that might still be n squared though, because if I have something like this and I'm checking if the difference 3 is possible, I would need to check 1 against I really just need to check 1 against 4, right? Oh, okay. If I'm checking if that literal difference is possible, then I just need to check if, I'm checking if the difference of exactly 3 is possible, I just need to check if, when I check 1, if there's either a -2 or a +4, that's at least that distance apart. This does allow repeats, which is irritating. Okay, so if I sort it with the index, that doesn't help me at all, actually. Okay. So basically, what I'm going to do is I want a map that will give me the indices of each value. Okay, equals empty array. So this is just going to make it so, like when I want to check if there's something exactly 3 apart from 1, I will check if there is something with, I don't have to check -2, but it's not worth optimizing for, so I check if there's a -2 in the array, and if it has an index at least 3 apart from the index of 1, and I'd check if there's a 4 in the array, and if it has an index at least 3 apart from -1. So I just need to check the max and min index of each thing, basically. Okay, this will work. So I'm going to do nums.each with index, do num I, indices num, shovel in I. Easy peasy. Okay, and I'm just going to make sure this works, because why wouldn't I? Not implement. What? Does it not like that I don't return something explicitly? What if I return like a 1? Like, is this a real error versus wrong answer? Okay, yeah, it's just, it didn't have an answer it liked. That's fine, because it's expecting a number. Okay. So, the minimum absolute difference, I assume x is always valid. It's less than numbers.length. Right. So the minimum absolute difference would be, at most, the max difference. Right. So, max diff, why did I capitalize that? Is going to be nums.max minus nums.min. Okay. Now I'm going to check and I'm going to make this a class variable so it's easier to access in a helper function, because the alternative is passing it in each time. So the minimum difference is going to be 0 to max diff dot b search k valid k, and that's not a very clear name. Wait, binary search means that it has to be true for everything after. So my function will have to allow differences that are smaller as well. Oh shoot, that doesn't work. Okay, let me rethink this. So I can check a difference if a specific difference is possible by checking if there's a number exactly that much apart. But can I check if there's a number that is more than that or less than that without iterating through every number? Like I can check x of 3 and O of n, I'm just not sure if I can translate this into binary search. Because in this example, I would check x of 2 and that wouldn't work. And so then I would, x of 2 does work. I would check x of 4 and it wouldn't work. So then in a typical binary search, I would say, well, 4 is too low to be the minimum, which means I need to go higher. Shoot. That's no good. I could check. Okay. Dang. I'm struggling with this one, man. Plug in my computer. This really feels like it should work somehow, but num0 of 1, right. Again, this is easy to do in O of n squared. How do I optimize, though? O of n squared is too slow with 10 to the 5th. Num0 is 1, num6. So I know the indices of each thing. I can check a specific value. Nums can go from 1 to 10 to the 9, so that doesn't work. By the way, that's another suggestion, that it should be binary search, because that's going to be 10 to the 3, which means it's overall 10 to the 8, which is around the limit. Okay. How can I do an O of n binary search? What if for every point for every I know the min value and the max value of everything that comes after it? That way, I could check in O of n what the smallest difference is. I think that's a better approach. Okay. So what I want to do is find the min and max value after each index. That's at least x from each index. So min equals hash.new, and I'm going to default this to nil. Max equals hash.new, and I'm going to default that to nil as well. Okay, so starting from the negative x element, actually default that to, the min should default to infinity, and this can default to 0. That way they're numbers that I can compare. Okay, so I want to find the min or max value after each given element. that's at least x apart. So I believe I would start from, if it's at least 1 apart, I can't start from -1, I start from -2. So I'm going to go to 0 to, no, -x minus 1. Okay, now I'm going to go from 0. That's probably going to cause me fewer problems. 2 nums dot length minus x dot each do. Actually, I just want to make sure that this seems like a dumb off by 1 error. Okay, so that should give me 0 and 1. Good, because those are the ones I'm comparing. That doesn't work at all, though, because it's not the min or max value. It's the min or max difference. Okay, so from 3, I compare it to 4. From 4, I compare it to 2 and 4. From 10, I compare it to 15. From 2, I compare it to all of them. 3, I compare it to all of them. That's a comparison I can do in binary search. Oh boy. Okay. So, nums equals set. That each do I. Nums dot add nums I plus x. Okay. I don't want to sort this every time, though. So what I want is for this to be added to a sorted array, basically. Like binary insertion sort. Because I can't just have it be a set. Can't just do the max min. Dang. So my issue is I'd want to have a sorted set so that I can, in each one, find the closest number using a binary search. But I can only do that if they're sorted, and they're not. There's got to be some clever way to sort this. And this is just medium. I'm struggling on this. I think this is a question I can get, though. So I'm going to take a break by looking at the next question, which is harder. And that will make me feel better about this one somehow. Okay. Apply operations to maximize score. Choose a non-empty array. And what is a prime score? What? The number of distinct prime factors. this might be a really dumb question, but nums 5 is the only... What? I see. 2 and 3 have a prime score of 2, but nums 2 has a smaller index, so we multiply by nums 2. The smallest index. Okay. Choose a new subarray. Choose the element with the highest prime score. Interesting. Okay. Okay, so the reason I don't do 19 and 18... Dude, this is wild. I want to get back to this. Looks like a really interesting question, though. Okay. Right. The minimum absolute difference that are at least x indices apart. So I can find the min and max, but that won't necessarily be the minimum difference because I really want anything in that range. I could do a binary insertion sort each time. That seems like binary insertion sort, like that should be n squared as a sort though, right? That's basically the same as bubble sort, or rather n to sort, but I'm doing that for each thing I add in. Binary insertion sort does run quicker though, so I'm actually going to try it. Each do I r dot b search index k greater than I, or if none of them are greater than 0, r dot insert I, not greater than I, greater than nums I. X equals, okay. So basically I'm finding the index of the first number that's greater, then inserting it. First, I want to see if this array is doing what I want. So the first one should be 3, 4. Oh, that's no good. I actually want to insert not nums I plus x. Okay, so that's the first fix. That's not good at all. Okay, so if none of them are greater, then I want r dot length. Then I would actually insert it in the last position. Great. So this gives me a sorted array each time. Min diff equals float infinity. Now that I have my new array, I'm going to compare that to nums I. Okay, so nums I dot, so now I'm going to do r dot b search index. Okay. Okay, so this was to do an binary insertion sort. This is to actually find where the nums I that I'm comparing is, so I can find the closest thing to that that's in my array of things that are at least x apart. So this is again going to be k greater than nums I, or r dot length. If none of them are greater, then I put it as the last one. Okay. So diffs equals empty array. Diffs shovel in nums I minus nums idx. So I'm going to do this difference if it exists, and I'm going to do, so that's the difference between the first one that's bigger. The one that's smaller would be immediately less than that. idx minus 1 dot abs, and this one will definitely exist, because even if it's 0, then I just do the last element in the array, which, like, it's not going to be the smallest difference, but it would work. Okay. So test diff equals diffs dot min, and then min diff equals test diff if, I'm just going to do diffs dot min. Because there are really only two. Okay, so the way I think this works is I'm iterating through everything that could be one of the two elements, so from 0 to minus x, because I'm only doing the comparison, comparing each element to a later one. I ignore the last x. So for each one, I first insert it into the sorted array with binary insertion sort. I think this is technically O of n, but it's quick and it is like log n. We'll see how that works out for me. Fingers crossed. Then I'm doing a b search index to find exactly where my element would go in this sorted array, so I can compare it to the two things next to it, find the minimum difference. This one might not exist, but this one will. So either way, I have something to compare, and then I do the min diff. This gets me 0, 0, and 0. That is not a good sign. How the heck does that work? Okay. I'm comparing nums I, not nums idx. Nums I and array. Okay, right. I'm comparing 4 to 2. Oh no. I'm doing this the wrong way. Dot 2a dot reverse. There we go. 1, 0, and 0. That's literally the opposite of what I wanted. So this comparison's right, but okay, so there's a greater than or equal to issue. That's fine. That might be what's causing the issue with the repeats. No, that's not it. What the heck? So this is giving me the correct array. It's doing the comparisons each time, so this should get 0. Right? Except none of them are greater, so I do 2, 2 and 1. IDX, so that's where I insert it. Right? Okay. But then I'm comparing 4 to... How does this always get 0? How does it get 1 that time? That makes no sense. What am I missing here? I should be comparing 4 and 2. Right? Why? Okay, right. That makes sense. Now, though, I'm comparing 4 to 4 and 2. It's like it's comparing the number 2 instead of the number 4. Here, yep. Here I'm comparing 2 to 10 and to 15. Here I'm comparing 3 to 2 and 0. That's no good. Because it's comparing itself. Oh my gosh, because did I insert it? I didn't insert it though, but maybe this should be +1. That seems wrong. Okay. Right, so those are both 4. I don't need to print the diffs. I can do that mentally. Okay. Where the heck am I getting a 3 here? Oh my god, I'm comparing to nums instead of R. That's my issue. Now it should work. Nil can't be coerced into an integer on line 30. If R IDX, there we go, 0, 1, 3. Perfect. This does work. It's still technically O of n squared, though. I think it's faster, but I'm not sure it's fast enough. Yeah, okay. See, this is a disadvantage to thinking big O complexity, because it's technically still O of n squared to do a binary insertion sort, but it's sufficiently faster, at least in Ruby, that it works like n log n. Okay. I want to check how I'm ranking before I go back to the super difficult problem I have no idea how to solve. because why not? $50 minutes. I could do that. That might be possible. And I've had only one 5-minute penalty. Okay, you finished in 15 minutes. That's pretty impressive. Right now, my rank is not bad, but people will pass me. Okay. Top 5% though. Okay. The highest prime score. Interesting. The maximum score after at most K operations. Okay. Of course it's 10 to the 5th. So first, I don't want to calculate the prime score of everything all the time. I want to do nums.map, num prime score num. This is going to be really annoying to calculate each time. Ooh, distinct prime factors. Great, love it. These nums go up to 10 to the 5th, which means the prime numbers are only going to go up to the square root of 10,000. That's going to be 316, 317. I could generate these. I don't really want to. List of primes up to 500. Great. 317. I don't think that should matter though, because 317 squared would actually be over 10,000. I'm going to try it like this. Okay. Ooh. Okay, I know what that was. I have something timeout after I'm inactive on it for like half an hour. Okay. Prime score. I lost my train of thought though. So total or score equals 0 until num equals 1. Prime equals until score equals 1. If num divided by primes I equals 0, then score plus equals 1, and while, see, I'm doing a while condition that's exactly the same as my if condition, because I want to increment the score by, you know what, actually, let's do it this way. I don't like doing the if inside the while. So, until score equals 1, while if, oh my god, this is more difficult than it should be. So until score equals 1, or until num equals 1, excuse me, or I equals primes dot length if num divided by primes. So if it can be divided evenly, equals 0. Prime factors shovel in primes I, else I plus equals 1. Prime factors shovel in num unless num equals 1. Okay, so what this is doing is it's going to go through every prime from 2 to 313, or until num gets to 1. If you can divide by that prime, it will divide by that prime. Otherwise, it will increment I. So eventually I get to num equals 1, or I get to the end of the list. I have all the prime factors so far. If num doesn't equal 1, then I want to put it in the prime factors array as well. So I could have something like 317 as a number. I don't have to check to divide by it, because I only have to check up to the square root of the maximum of n. But it could actually be a factor, right? It would just be the only remaining prime factor. This is common for primality tests. You only have to check by going up to the square root of the number to see if it's prime. Because if none of those divide it, then your remaining number has to be prime. Because if it weren't, you'd have to multiply it by two things that are each bigger than the square root. And if you multiply two numbers bigger than the square root, you get something bigger than your original. Anyway, so I check up to the square root. I add it if it's not 1, and then I just return the length. So let's see. I just want to see if this is working correctly, first of all. So 8, 0, 3, 0, that's not good. That's very not good. Why is prime score returning 0? Oh, I need to actually divide it also. Although that seems like a reason it just wouldn't end more than anything. What? Okay. So I put in the prime score of 8. I does not equal primes dot length. What the heck? That was why I test. Until num oh my god. Until num is equal to 1, I'm not setting it equal to 1. Okay, so that's, oh yeah, that unique dot length. There we go. That's easier than making a big array. So 8 has 1, 3 has 1, 9 has 1, 3 has 1, 8 has 1. Great. 19 has 1, 12 has 2, 14 has 2, 6 has 2, 10 has 2, 18 has 2. Okay. Lovely, lovely. Oh my god. So this is every possible subset I'm potentially checking. Okay. So how do I go about this efficiently? So in this case, I'm just choosing the biggest numbers, right? So I choose 9, and then I choose 9, including something else. Yeah, fair enough, because they all have 1. Here I choose 19. I can't choose 19 and 12, so I do 18. And then I could just do 14 by itself instead of 14 and 6. Doesn't matter, but if I got this again, then I would do 14 and 6 for the second time. And then basically, okay. So 19, I want to select only, I can only select it in 19. 18 is 2. What? Why am I not? Oh, because it's the one with the lower index. Right. So if I do 18 with anything else, it'll actually be the thing before it, except, right, because that's the maximum. So for each subset, I would choose oh boy. Okay. So I do a subset starting with 19. 19 is going to matter for only by itself. Whereas with this one, it's just going to be whatever is first. I could do 9 by itself, I could do 9, 3, I could even do 9, 3, 8. Either way would give me 9. Oh man, there's got to be a way to do this efficiently. Seriously though, 10 to the 9, that's insane. Okay, this is O of n, O of 1. Which means that's going to be O of n. That's fine. This is distracting and bothers me, so I'm getting rid of it. No. This part's solid. So basically, for each subset, I want to find what number will be chosen. Okay, so thinking about it from, well, this is a terrible example. I need a different input example. I need something that will increase and be a little more interesting. So I'm going to say 7, 14, 16, because that's 1 again, something with 3, 30, something with 2, 15. And say I want to pick 4 from here. Okay, right. So starting here, okay. So here it would be 7 if I do the first, and it would stay 7. Okay. So anything starting from that will either be, if it's still 1, it's going to be that first thing. If it's anything bigger than 1, it's going to be the next thing. Now, I can do this. So I just want to do the value based on the starting point and the ending point, right? This seems like dynamic programming. The value here, going to itself, is always going to be itself. Going to the next thing, if it's the same prime factor, then it doesn't change. Once it does change, though, then it's going to be the same as this thing going there. Fine. So this thing going there doesn't change. Now it's going to be the same as this thing, though. So if I'm starting at 14 and I go to itself, that's the same. So if I start at 7, it will be 14. If I start at 5, it will be 14. If I start at 14, it will be 14. Okay. Okay, so now I can do this more efficiently. I'm going to say nums.map memo equals I'm not sure I can actually do the whole thing, so I'm going to do this as an object. And I'm going to have a function that's basically def val from I to j. Okay. Return memo ij if memo ij. So I can definitely memoize, so I can quickly get the value of any subarray, right? Array.new nums.length j return nums I0 if nums if I equals j. Otherwise, okay, so while, okay, so k equals I, while k less than j, k plus equals 1, memo I, j, return memo ij equals val of kj if nums at k1 greater than nums at I1. Otherwise, I would say at memo ij equals nums I0. And I don't even need that return statement. Okay. So just testing this, I want to do val from, let's say for all of the arrays, I go from 0 to 2. That's not great. 16 nil class nums k 1 greater than nums I1. So j doesn't go outside of my array though, right? k equals j, then that's fine, because then I just do the value of I. If k does not equal j, what? Where am I getting a nil class? Is it not like something about my memo? Num. That's a dumb typo. Okay. So this should work fine. I believe this calculates the minimum for each subarray. 8, 12, 14, so that's 8 and 9. Yep. Yep. Perfect. Okay. So I have a val. Now I can find the value for each subarray efficiently. However, I think that has to be part of the solution. So I can efficiently calculate the value for each subarray. I do know that they follow a pattern, but I mean, I'm just going to try this, but it's totally not going to work. Vals equals this, so I'm going to do 0 to nums.length dot each do I. Now this would be I to nums.length dot each do j. Vals, shovel in val ij. Vals dot sort. Total equals 1. K dot times total times equals vals dot pop, and return total. So this should work, but it's going to be O of n squared, and it's going to be too slow. 81, 47, 88, 81,000. Oh sure, because 30 is my biggest number, and I do 30 4 times. Easy peasy. Runtime error. Oh boy. Oh, yeah. Yeah. Okay. So each of these memo things is just going to be a single number, but I do need to do the mod each time. So total equals total times vals.pop mod 2, 3, 4, 5, 6, 7, 8. That. So now it will work, but it's going to be too big. And just to make sure it works in the first place, run code. Yeah, that's a number. This is going to be too slow, though. What? Oh my god. How did that not come up earlier, though? Real talk. TLE. Yep. Oh, yeah. Because I can't generate each subarray. So basically for each number, I need to figure out how many numbers, it's the subarray. Right? Okay, I can do that. So, okay. So basically, a number will be the number used in the subarray if going forward it's the val and going backwards it's the val. It'll just be everything including that max and min. I'm expressing myself very clearly. Take 30. So 30 is going to be the subarray in everything that starts 30 or earlier and ends 30 or later, because it happens to be the biggest. That's not a great comparison, so let's actually take 14. So 14, we check. 5 and 14 work, 7 and 14 would work, meaning anything that starts with 7, 5, and 14 will be 14 if it includes 14. 14 and 16 also works, but 14 and 30 doesn't. So that gives me 7, 14, 7, 16, 5, 14, 5, 16, 14, 14, and 14, 16. Those would be all the ones that contain 14. There are 6 of them because there are 3 numbers going up to 14, boop, 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 and there are 2 numbers on the end with at least 14. This should work. So for each number, I'm going to get a min and a max. Okay. Oh boy. Okay, so I'm going to say min IDX. I want to find the min IDX and the max IDX of each thing, basically. Min IDX equals hash dot new. This probably doesn't need to be a hash. This is going to work though. How much time do I have? I can do this in like 20 minutes. 22 minutes. Perfect. Okay. So basically it takes the number and it's going to be the number of times I can go backwards, actually. Start at 1, and start this at 1. So, nums dot each with index, do num I. Okay, so min equals min max equals I, while nums I minus, well no, while I greater than 0 and val of I minus 1, I equals val of I, min minus 1I, min minus equals 1, same thing for max. So basically I'm saying, again looking at 14, I know that the val of 14 of 2, 2 is 14. So I'm seeing, can I go backwards? So I'm seeing, what's the val of 5i, of 5, of rather 1, 2, but representing 5 and 14. The value of 1, 2 is still 14, so I can go backwards to at least 5. 0, 2 is still 14. Great. Okay. I'm going to do the same thing with max. So while I less than nums.length minus 1 and val I max plus 1 equals val I max plus equals 1 end. Okay? So now I'm just going to do min index of I equals I minus min plus 1 max index of I equals max minus I plus 1. The plus 1 is because I count itself, so min index is just the number of different indices I could start with. So for example, again with the 14 case, if I'm starting with 0, 1, or 2, 2 minus 0 is 2, but I add 1 because I could count 14 as well. My ending index is going to be 3 minus 2 is 1 plus 1 because there are 2 possibilities. Oakley dokley. And let's do min idx, max idx. I just want to see that these are both coming through correctly. Oh my god, why? Right? Oh, not while max is less than. And this is while min is greater than. Why? P, and let's call this 4. Not dealing with this formatting nonsense. Okay. So in the first one, yeah, that's only going to be itself. And that will be the same for all of them. Great. Okay, so there are 5 ways to use that first H, then 4. Great, great, great. One. I could start the 19 or 12. That would have to be 14. That would have to be 6. That would have to be, okay. Great, this is working. Okie doke. Okay, almost done, almost done. So now I can sort the indices by the value at that index. Now having done all this, I can map them back to actually I can just use nums. 0 to nums dot length. Okay, so order equals 0 to nums dot length dot sort by, so this is I, and I want to do nums I, and I actually want it to be reversed, so I'm going to do negative nums I. So this should just get the indices in order of value. Yep, so that's 9, 8, 8, 3, 3. This is 19, 18, 14, 12, 10, 6. Great. Okay, I'm almost done. So total equals 1. while k greater than 0. Actually, don't even need to reverse this. I could just pop. Val equals, actually, idx equals order dot pop, ways equals, not val, min index idx times max index idx. So if if ways greater than k, total times equals okay, so if I'm running out of k, that means I'm going to do k of these. That's just going to be pow of the number I want is going to be nums idx to the power of k mod, I'm going to make this a class variable, 1, 2, 3, 4, 5, 6, 7, 8, 7, mod, return total, else, k minus equals ways, total times equals pow nums idx ways mod. This should work. And if it works, I'll explain it a bit more fully. If it doesn't, I'll also explain it a bit more fully. Undefined method pow. You're right. How do you do pow in Ruby? I believe that then it's going to be dot pow. To the power of k. I'm doing to the power because that's more efficient than actually multiplying each time. No, what? Oh, yeah, that's the dumb one. Okay. I'm actually going to do total mod in here. Okay, that should mean my mod's working correctly. Yep. And now I think this is going to be too slow because I think it's a specific thing about, or not too slow, I think it might exceed the maximum number because of a specific thing about how power works, so I need to put mod inside power. It shouldn't time out though. It might exceed the maximum output. What? No. How? There should be 15 possibilities. Why would that? Okay, that's really confusing. I'm going to try the power fix anyway, but I don't think that's... Actually, I'm going to try not doing mod. And see if I get some version of the right answer. It's still no. Why is that no? Okay, so that should be 1. Am I not getting all the possibilities somehow? I must not be getting all the possibilities because I run out of things I can do. What the heck? Okay, so 7 should be for all of them, right? So that's going to be, there should be 15 in total, so I get 1. Aye. Come on. I get 1 from 1. Quit highlighting like that. What the heck? From 7, I get 2 times 4, so that's 8. That's 9. From 11, I get 1, 2, 3. That's 12. From 1, I get 1. That's 13. From 5, I get 2 times 1. That's 15. Right, so 1 is obviously the last one I would use. What is order in this case? Why am I getting no? Right. Index equals ordered out pop. Oh, what if k equals 0? Greater than or equal. Okay, that's why I'm getting null. That was dumb. Okay, this will either, it shouldn't time out, it might exceed the size of a number, and that just means I need to refactor POW. What the heck? Why? So that should be every combination. One, 5, 7, 5. How would that multiply differently? I'm so close to having the right answer here. Like, my strategy is fundamentally correct. I'm very confident in the strategy. First, I just want to see if this works. This is going to be the same issue. I don't care about my penalty. I'm trying to learn. Okay, great. So, how much time do I have? 6 minutes. Lovely. Could go either way. Why does that not give me the right number? So the 12s are going to dominate everything. So this is going to be 1, 2 times 4. That's 12 to the 8. Plus 12 to the 3. So that's 12 to the 11 plus times 25. So 12 to the 11 times 25. One, 2, 3, 4, 5, 6, 7, 8. 209. And that's what it should be. I think I have a mistake in my mod then. 10 to the 9 plus 7. Well, let's try doing it that way. That's not good. 5 ways to get 12. Oh no. I see. Okay. So it also needs to not work if that is... Right. Okay, I'm going to go over time a little bit because I think I'm really close. I realize that I won't finish in the contest time. Probably. Maybe. Okay. So nums.h with index. Okay. Okay. I see. So when it's repeated, 12 is repeated in both those cases. I'm mistakenly counting the second 12. Yeah, I'm definitely going to go over. So this 12, I need to stop when it gets to here. So basically, I need the indices to be different or the numbers to be different. Okay, that's a pretty easy condition. And I equals min or I want at nums I not equal to nums min. Okay, this should work. This should fix it. Oh boy, what now? Why did that not work? So that was equal. Either the index is the same or the numbers are different. This shouldn't make a difference, but I'm going to try it anyway. And then be disappointed. Why does that not work? Because the max issue is fine. I can keep going if they're the same in the max direction. I just can't in the min direction. Okay. And so the min is greater than 0. I can subtract. And the value of min minus 1 is the same as I. Oh. And nums at I unequal to nums at min minus 1. Come on, come on, come on, come on. 31 seconds. Down to the clock. No! It's too slow. Why is it too slow? Am I printing something? I'm not printing. No. This shouldn't be too slow. I shouldn't need that. No. Okay, I do need that. Oh, right. I'm over though. Why is this too slow? Can that be n squared, though? Yeah, yeah, it's n squared again, because each thing could keep going. Shoot. Okay, so the reason this is n squared is in building out the max index. Min, I think, is actually fine, because it has to be a different number. Maybe not. Max is definitely not fine. You could just keep having the same number over and over again, and then it becomes n squared. Shoot. Okay. I think I'm close. I think I'm along the right track. My min and my max still are not optimal enough, because this is still n squared. But I have working solutions to everything here. Val works, order works. I just need to figure out how to make min and max more efficient in the case of repeat values. So I think what I need to do is find points where it actually changes. For max, I just need to find the change points. And then only check those. Would that work? I need to find a way that I can generate the min and max that's not O of n. Min index and max index. That's not O of n for each thing, O of n squared total. I don't quite have the efficiency there yet. So I need to figure that out, and then I have a working solution here, because it works. Let's see how I actually ranked. Dun, 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 dun. Right. I don't remember offhand what my thing was, except I was 11,000 at one point. I'll have to look this up. Anyway, this was my attempt at weekly contest 358 virtual. First 3 questions done. This one I have a working solution, but it's not quite optimized enough yet. That's it. Bye.